For a century, modern physics has struggled with a division: the physics of the very large, governed by general relativity, and the physics of the very small, governed by quantum mechanics, refuse to speak the same language. The standard approach to fixing this disconnect has been to invent increasingly richer, more complex mathematical structures in an attempt to bridge the gap. This effort produced candidates like string theory, loop quantum gravity, and causal set theory. Each model extends the known laws of physics by injecting extra dimensions, new mathematical objects, and new symmetries into the equations. These models often yield tantalizingly accurate predictions for specific problems, but eventually, every single one of them hits the exact same conceptual wall. Forcing unification purely by expanding the math without changing the foundational assumptions always results in structural failure. The wall these theories hit is a problem of selection. The expanded mathematical structures begin producing predictions that rely entirely on arbitrary choices, like picking a specific vacuum state, a basis, or a background geometry. In string theory, this is known as the landscape problem. In causal sets, it's the preferred frame issue. The vocabulary changes, but the disease is identical. There is no internal physical mechanism within these theories to tell us which of these infinite competing pathways correctly describes our actual universe. The disease has a single cause. Every one of these models treats the observer as a free parameter, a variable plugged in at the very end of the calculation, depending on who is asking. Without the observer explicitly written into the foundation, a theory of everything uncontrollably blooms into a theory of almost anything, depending on the choice. The observer-dependent theory of everything, or ODTOE, addresses this directly through a reversal of perspective. Instead of piling on richer math and hoping the observer issue resolves itself down the line, ODTOE postulates the observer as a fundamental primitive. The core axiom states, reality is defined as R equals O hat of psi. Here, the observer and operator are the foundational data. From this starting point, the universe's mathematical apparatus, configuration fields, and spatial geometries is constructed specifically to be consistent with that reality. In this framework, we do not derive the observer from the universe. We derive the mathematical laws of the universe from the presence of the observer. This shift immediately addresses long-standing bottlenecks in physics. The famous measurement problem in quantum mechanics, for instance, simply dissolves. The measurement puzzle was an artificial problem caused by leaving the observer out of the initial equations. Once the observer is foundational, a measurement is the native application of the mathematical operator. There is nothing to puzzle over. The infinite landscape problem of string theory also becomes manageable. ODTOE introduces a selection principle based on coherence. Vacua with low coherence are discarded entirely because they mathematically cannot sustain observers. From here, ODTOE naturally extends its framework. The exact same configuration fields that govern particle physics also govern cognitive systems, biology, and AI. Most candidate theories cannot discuss cognition without smuggling in unscientific extra postulates. ODTOE speaks about it natively. By anchoring physics to the observer, the framework clears away structural mysteries that purely mathematical theories cannot touch. ODTOE does not promise that everyday physics calculations will suddenly become easier. In most cases, they don't. Calculating a particle cross-section at the Large Hadron Collider is no easier in ODTOE machinery. The standard model remains the correct tool for that specific job, operating as a low-coherence dimensional configuration of ODTOE. It also doesn't magically generate the exact numerical constants of nature from sheer math. Instead, it constrains those constants to whatever is compatible with observers of our specific dimensionality. ODTOE's true promise is not a computational shortcut for engineers, but a structural unification for our understanding of reality. Because of this, ODTOE does not seek to eliminate competitor theories like string theory or loop quantum gravity. It absorbs them. Contemporary theories can all be placed into a single configuration space, ranked mathematically by coherence and observer dimensionality. Specific tools from other theories find their exact place here. The spin networks of loop quantum gravity function as natural representations of low-dimensional ODTOE configurations. ODTOE provides the foundational anchor that prevents the mathematical choices within these other theories from running away into infinite branching paths. A unified map of physics is achievable, but building it required reversing the way we approach the math. To accurately map the universe, science first had to stop ignoring the fundamental role of the one looking at it.